Exercise 4. So, if 16 plus 4x is 10 more than 14, what is the value of 8x? Well, okay, 10 more than 14 is a very fancy way of saying 24. So we have an equation, 16 plus 4x equals 24. Now we can solve this. We can calculate x by um, subtracting 16, and we have 4x equals 8. And yeah, now we can divide by 4 and calculate that x equals 2. But if we want a value of 8x, then it may be faster to just multiply both sides by 2. And we get 8x equals 16. So the answer is C. One step less, because normally we would have to divide by 4 and then multiply by 8, which is kind of not, we don't need to do this. We can just multiply by 2. Okay, so exercise 5. Let's see. Exercise 5. Which of the following graphs best shows a strong negative association between D and T? Oh, I like this question. This is statistics, but true statistics. In Poland, statistics is learned in a way that what is arithmetic mean, what is standard deviation and variation, and that's all. That's all. Without any context of how is it used, without any saying about analyzing the data. So I don't really like this. Most people in Poland have no clue what statistic is all about. They just think, oh, they are calculating the mean averages and that's all. No, statistics is so much more. And this question is one of the examples of how statistics is really used. Strong negative association, what does it mean? This means that if D is rising, then T should be decreasing. Or if D is increasing, then T is decreasing. Positive association would be if D is increasing, then T is also increasing. Or if D is decreasing, then T is also decreasing. Here what we can see, well, the answer will be D. Here we can see that if D is bigger, then T becomes smaller. In C we have strong positive association. In A, well, I would say that this is a situation when the variables are independent, which means that the value of one doesn't really matter for the other one. Maybe a little bit some negative association, because we can see that the highest levels of T are when D is small, but not very strong. I would say it's closer to independent than to the negative association. In B, we can see that, well, T has just low values no matter what what the value of D is. So there would be also not, they would also, I think, be close to independent. So here the answer is D. And of course, we are now just talking things. What do we see in a picture? But in reality, statistics doesn't work like this. We can, in real statistics, we can take the values and calculate the correlation, and then we can see if they are strong negative or positive association depending on this correlation coefficient, which can be from -1 to 1. And if it's close to 1, then it is a positive association. If it's close to -1, then it is negative association. And when it is around 0, then it doesn't mean that the variables are independent. It just means that they are uncorrelated. But a lot of this you can see on a picture. For example, in those two last examples, you can see this strong positive or negative association. Okay, so exercise 5 would be D, and now exercise 6. What do we have there? 1 decagram equals 10 grams, 1000 milligrams equals 1 gram. A hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in 1 decagram container? Okay, so how many 1 milligram doses in 2 decagram containers? So 2 decagrams. Okay, I don't need this table because, well, in Poland we are using SE, but 2 decagrams equals 20 grams because 1 deca is from 10. Decagram is 10 grams. Decameter decameter is 10 meters, decameter. Decanewton would be 10 newtons, and so on. So this is 20 grams, and now milligram, milli means 1000. So milligram, 1000 milligrams gives 1 gram. 1000 millimeters gives 1 meter. 1000 millijoules gives 1 joule. You can also say this in imperial units. For example, you could just make, for example, millifeet, and it would just mean that 1000 millifeets is 1 feet. It doesn't really fit to this to imperial units because they are not using those prefixes, but you can create this and it would work the same like here. So 20 grams, well, every gram is 1000 milligrams, so 20 will be 20,000 milligrams. Based on the information, how many 1 milligram doses are there in one 2 decagram container? 20,000. The answer is D. So, one short thing about the units. I prefer our, well, not only European, but most of the world uses SI. I prefer our system because it has these prefixes that tell you basically how many of one unit is you need to get the other unit. And these are always numbers like 10, 100, 1000. I think it's much simpler than, for example, 12 inches equals 1 feet and 3 feet equals 1 yard, which means that 12 times 3, so 36 inches gives you 1 yard. Now imagine calculating the volume, for example. If you have 1 meter cubed, it's, well, every meter has 100 centimeters, so 100 to the power of 3 is 1 million. So 1 meter cubed equals 1 million centimeters cubed. And it's pretty simple to calculate. On the other hand, in imperial units, if you would have 1 yard cubed and would like to calculate this in inches, then you have to calculate 36 cubed inches. 36 cubed inches. This is 6 to the power of 6. And, well, of course you can use a calculator, but for example in Poland in first 8 years you cannot use calculator, only in special cases. And now imagine calculating this 36 to the power of 3 when you are 12 years old. In Poland, that's a typical question. How many centimeters cubed are there in meter cubed? Because it's simple to calculate. I don't really imagine the same question for 12 years old without using calculator. How many inches cubed are there in yard cubed? So that's why I think SI is way better than imperial units. Thank you for watching my videos. If you like it, please subscribe and turn the notification bell and do all this stuff that happy viewer does after watching a video. And well, have a good day. Bye.